right, so the first topic, I guess, that we're going to go over as part of the summer assignment is order of operations. This should definitely be a review. I think probably the first time you really looked at this might have been in middle school. Maybe before, probably not before. So first is parentheses, exponents, multiplication and division as one step, and then addition and subtraction as one step. So some students remember this by saying, please excuse my dear Aunt Sally. Other students remember PEMDAS. However you want to remember it is fine. The important thing to realize about the first one is that while it is often parentheses, it's not only parentheses. So the first one is to simplify anything that's inside of grouping symbols. So that could be something where you have a bunch of stuff underneath a square root sign. It could mean you have a bunch of different stuff in an exponent. It could mean you have a bunch of different stuff underneath a fraction in the denominator or in the numerator. So step one just means you're grouping, you're simplifying anything that has been grouped. And typically we see parentheses, but it's other stuff too. Exponents would clearly be your exponents, but they could also be things that don't often show up as exponents, like square roots. So a square root sign is an exponent of 1/2. That's something to consider as well. And then for step 3 and 4, some people don't realize that multiplication and division is actually considered to be one step. And you just do it from left to right. So you do not do multiplication first and division second. That's not how it works. It's both at the same time, from left to right. Okay, so I have a few examples to go over with you. The reason that we're doing this as one of the units is because a ton of calculus is work, nitty-gritty algebra that you have to do by hand. And what I found is that students are often uncomfortable when they're given problems that are maybe not as clean looking as what they've experienced in the past. And when we get to calculus, a lot of problems aren't clean. And a lot of answers are not just like simple whole numbers. So this is the first example we're going to do. We have 1/8 times e to the 5/3 times 3 minus 5. So this is our grouping right here. It's not all in parentheses, but it is definitely being grouped. And then these parentheses we have over here do not mean grouping, they mean multiplication. So PEMDAS, clearly not as straightforward as your middle school teacher told you. All right, so the first thing I'm going to do is work with the stuff that has been grouped. So I know that 5/3 times 3, that those 3's would cancel. And so I've got 1/8 e to the 5 minus 5. And then typically what I do, I guess I don't do one step at a time. I don't do all the problems in 4 steps, but I kind of simplify each individual term. And you guys are advanced enough in math that for the most part I trust you on this. I just want to go through an example that would make a lot of students uncomfortable. So I'm going to go ahead and do this step next. I've got 6 multiplied by 3 squared. So that's going to be 6 times 9. And then 5/4 times 3. I can think of this 3 as being a 3 over 1, and when I multiply fractions, I go straight across. So I've got 5 times 3, and then 4 multiplied by the little 1 that would be underneath that. So that's going to be 15/4. Okay? And then from there, I can say that 5 minus 5 is 0, so I've got 1/8 times e to the 0, plus 6 times 9 is 54, minus 15/4. And 1/8 times e to the 0, e to the 0 is just 1, so 1/8 times 1 is 1/8. And at this point, I do need to combine all those terms together, and so I'm going to have to get a common denominator. So this one and this one are going to be pretty easy. To get this to be in terms of 8ths, I'm going to multiply the top and the bottom by 2. So I have 30/8. So 1/8 plus 30/8, sorry, minus 30/8, because that's a negative. That'd be negative 29/8 plus 54. And then at this point, I need 54 to be written in terms of 8ths. So I'm going to say 54 is 32. 40 plus 3 is 43. So I've got negative 29 eighths plus 432 eighths would give me 400 minus almost 30, 403 eighths. I feel pretty good about that. And then I don't mind if you want to go back on these and like plug them in with the calculator just to check your work. I really hope I got this right. I'm not remaking the video if I didn't. I'll just be like, whoops, made a mistake. You guys, it's early in the morning. I'm having calculator issues. All right. Yes, got it. All right, next one. Example 2. So here we've got 2 minus 1/5 over negative 0.3 minus 5. So what I'm going to go ahead and do first is get this all written in terms of fractions. I know that a lot of students are more comfortable with decimals, but when you're working stuff by hand, fractions are a little bit easier to work with, in my opinion. So this negative 0.3, I have to remember what my decimal places are. And so the first one after the decimal is tenths. So that means this is negative 3/10. So I've got 2 minus 1/5 over negative 3/10 minus 5. And so what I'm going to go ahead and do is my kind of grouping, right? The top is grouped, the bottom is grouped. And so I'm going to get a common denominator on the top, I'm going to get a common denominator on the bottom. So 5, 2 over 1, and I need it to be over 5, and so that would be 10 over 5 minus 1 over 5. And then this needs to be over 10, so I have the negative 3 over 10 minus 50 over 10. And so this would be 9 over 10, 9 over 5, sorry. 10 fifths minus 1/5 is 9 fifths, and then negative 3 minus 50 would be negative 53 tenths. And then I can go ahead and do keep it, change it, flip it. So I'm going to keep, or you can think of multiply by the reciprocal, which is very mathematically accurate, but not as fun as keep it, change it, flip it. All right, so I've got 9 over 5 times 10 over negative 53. And I can see that that 10 and that 5 simplify a little bit. So 5 goes into 5 once, 5 goes into 10 twice. So 18 over negative 53. When you're writing a negative fraction, you can leave the negative on the bottom, you can move it to the front, you can move it to the top. It does not matter. So again, I'm going to check my answer. Negative 18 over 53. Perfect. All right. And then one last example for you. Two times 1 minus pi over 6 plus 1. All right. So in this one, we do have those grouping symbols, but those are not like terms. I cannot combine a 1 and a pi 6. I could get a common denominator. I'm maybe just going to leave that. I could do it now, I can do it later, it doesn't really matter. So I'm going to go ahead and do the next step, which in this problem would be multiplication. So I'm going to distribute that 2. So I've got 2 minus 2 pi over 6 plus 1. And I've got 2 plus 1 equals 3. So 3 minus the 2 and the 6 would simplify to be 1/3. So this is a pretty good answer. Or if I wanted to get a common denominator, then I could say this is 3 over 1, so this would be 9 over 3 minus pi over 3. which is 9 minus pi over 3. Now, you'll notice that I show a lot of work. I don't do my intermediate steps on my head. I show them. Part of that is as a teacher, I want to make sure that you can see exactly what I'm doing. But the other reason I do that is when you are doing problems like this by hand, you are more likely to make mistakes when you do stuff in your head. So I would say unless you are really, really good at mental math, you need to write down your steps. And the reason I say that is when I am making answer keys on problems like this, I would say 9 times out of 10, if I'm rushing, I will not have the final answer correct. And it's not that I don't know how to do the math, clearly, it's that I'm going too fast. So be careful definitely of that when you're doing these problems by hand to make sure that you're showing all your work so that you don't make stupid mistakes. Now I'm still going to go back and check my answer, and I would say that's a really good habit to get into on any problem where you're not allowed to use a calculator, is just to check it when you're done, so that you don't find yourself making mistakes over and over and over again. So I typed in the original problem, I typed in my final answer, and my decimals match, so I know I'm good.